Hi, today I will make a video about how to connect ESP-01s module to Arduino to use it to interface with the inputs and outputs and various types of data. Also going to introduce how to use it into a Delphi project, and also how to interface from Arduino to Arduino. For doing this, I will use the best program for it. It's Visuino, and it's the easiest also, as I see it. So yeah, the ESP-01 module looks like this. It's a small Wi-Fi module, and it requires some pre-programming to operate fully. So we will do that, and for doing that we will use Arduino Uno, or that we will just use as a programming card that we then can load a program into this one by using this one, so we don't need any external programmer. For doing this we will also use Visuino software. Yeah, so that we will do tonight. So here now we are ready to connect the Wi-Fi module to the Arduino for programming. So we have the unit here. We have a bunch of cables here. We have our Arduino unit. So I also have a schematic I found on the internet. I'll add that to the screen here. So now we start connecting. First on the pin is the TX. We connect this one here, and it should be connected to the pin number 1 on the Arduino. So now we can cross out this one. See? Finish. Take the next one. We can take the RX. And we connect that to the pin 0 on the Arduino. So we cross out this one. We can connect the enable. This is a bit confusing about the name, but it says channel PD. So it should be connected to 3.3 volt. Since we only have one put on the Arduino, we will take it down to the rail. This is an enable signal, so it enables the Wi-Fi card. Next, we connect the reset. We want to have that. So even if it doesn't say so, we will connect it anyway. So we have the reset, and we can take the text here, and we can put ground to reset. Take the next pins. Now the color is maybe not the correct selection, but it doesn't matter. We have the VCC 3.3 on the card. We connect that to the positive rail. Next we have the ground. So we can take directly to the ground on the Arduino. And also for programming, as they don't mention here, we need to GPIO 0, we need to put to ground when it's in programming mode. So we will put up a text here. We connect this one. We can have that on the board here. This reset, the red one, you can have at the board. So we quickly can just change them. And we also take a ground point from the Arduino down to ground on the rail. That means when I need to ground the GPIO 0 port, I can just quickly move it over. And same for the reset, I can just quickly move it over. So now the connection is complete. Now we are back for the final step for the programming or writing to the flash of the Wi-Fi module. Now we want to have a clear sketch in the Arduino IDE first. So as you probably noticed that I didn't connect any power to this Wi-Fi unit still, and also a reset wire on the Arduino board. So as now we have Arduino Visuino opened, and we will just flash. You can see there is a standard blink program in the Arduino. So the first I will do have a clean program. A program the Arduino first with like a bare minimum. I don't think it's actually necessary, but it's recommended in all the guides. So now there is no more blink. And what we do now, we will connect the reset on the Arduino. Then that microcontroller on the Arduino Uno will not be active. It will be reset all the time. So we connect a short wire from the ground to the reset pin. And after that, we connect the positive rail that we had for the Wi-Fi card. We connect to the 3.3. So now we go back to Visuino again, and now we need to program an ESP device. So we have to select the board. We can double click here. We will see the board type, and we can search for ESP, and we have ESP-8266, that is the chipset, If we expand that one, it's not this one. Maybe it's this one. Yeah, the ESP under Arduino, and not on the Adafruit, but on the Arduino. And then on the ESP-8266, we will find ESP-8266-01. That is this unit. So we select that one. And as you see now, there is a lot of extra stuff we have here, like Wi-Fi, dual serial, other things, not so many inputs, outputs. So now, just to make a test, we can actually select a pulse generator. And we can put this out here. And we can scroll down. We take the output from the pulse generator in on the GPI 2 here, which is the LED on this unit, and also the one of the pins. It's a frequency 1 Hertz. So to program this one, there's two ways. Either we can disconnect the power, we can move the GPIO0 pin to ground and reset, or we can take the power and then move the wire and in with the power again, or we can move the reset that programming pin and then take a reset. In this case, I will just move the GPIO0 pin to ground, and then I take one dip on the reset, and we have a lot of stuff here now, more than I understand actually. But now we try to flash it. It takes some time to compile. Now it's writing. This was a success. So now we move the programming pin back and we do a reset. And as you can see now, there is a pulse coming out on this LED. So the programming of this is working. It's like acting like a standalone unit. So that surprised me in the start. So I like using Visuino because it's very easy. It's no driver. It's not a lot of code. Nothing to use actually. It's just ready to do like this. So I really like that. And it's very easy to set up. If we further look at this unit, we have a Wi-Fi unit here. So if we click on the unit, we will see on the side here we have modules. If you open that one, we will see Wi-Fi under the modules. So we can expand this also. And then short below we find connect to access points, this one. We will expand this one also. We can click on the three dots here and we can add a Wi-Fi access point. And now when we select this one here, we will have some configuration here. This unit I tested before, and it has actually it's working with the DHCP. But now for just showing, we will input the values manually. So we go in here and on the access point. Channel is okay. We can go in the config. We can set in the DNS. For now, I just use 192.168.50 and 1, which is the router I just set up now for use. We have to enable the DNS. And we have IP. We can set 192.168 and 50.10. And we set the gateway 192.168.50.1. And enable, and we have to set the SSID. This is Asus 10. This is the default router I just put up. 7454. I think that was correct. I think we have all the data we need. Oh, this looks okay. So now when this is set, we need to do the same procedure one more time. And we connect the GPIO pin 0 to ground. We dip it one time at the reset. Now it's in the programming mode. And now we can start the program. Start transfer. Take some time to compile. You can also show you the phone. So if I go into the show my phone screen. Sometimes it really takes some time to compile. we might try one more time. It took a long time. Now it's happening something. Writing. Finally. Yeah. That was a success. So now we move the programming pin away from ground, and we dip one time at the reset pin. We give him some seconds to wake up and connect. We can try to refresh again, and as you can see now, there is one unit coming generic. I forgot to set the host name, but that you can do here. But it's okay. Arduino 1. So now we can see it here. This is via my phone. We can ping the device. So that's cool. And we can show for open ports. Now it's none currently. We can also check from the command prompt there. I did it before, so ping this one. We can ping it. So I can show that the command prompt here also. So this is good. Now this unit is connected as a standalone unit. It connects to the Wi-Fi, and if it sends out any data or receives any data, it's needed to be treated here at first. So next now will be to make a socket and then connect some data to it. And then use a receiver to actually receive it. But this is how you have to program this unit at first. Then I'm back again after a short break. I think I will round this video off by just making a Delphi project. And then I want to make all the hardwares and maybe 3D print the boxes for it and solder it properly. So I think the power to the should be better than on a breadboard when you program. So I maybe think that was the thing that took a long time last time. So as we saw previously, we can ping the unit. This IP address we will use to connect, and now if we take this away, and we move into Visuino. We need to add a socket. Now we have a Wi-Fi connection now. So if we looking, I have to remove the phone also. So I'll do that. If we're looking down on the sockets here, we can add a socket, and for this we want Delphi to connect to this unit, the Wi-Fi unit. So we need to add a TCP/IP server, and when this is selected, we can go here and we can specify our port. Let's say we take 8080. And we close this one, and as you can see now, we have got a TCP server, a socket on port 8080 here. And normally you will like to send many types of data in the same structure. So for this, we need to add the make structure. We can add this here. And we need to connect output to input of the socket. And we can open, and for now I just think we take a one digital. Here we can add many types of data, as you can see. For now I just take one. And then we want to send out a pulse, which I will use for the LED on the Delphi project. And we need to connect that into the digital in. If I had made more components in the make structure, I can add different things, different values of things coming in. Let's, for example, say if you want to have something coming in on the Arduino. I already have the serial connection between the ESP and the Arduino. And for that, I can send the data in the same way in the make structure thing, and I can receive it down on the either serial or this other put. I don't remember what it's called. Using the SDA and the SDL pins, and then I could send it via out from the serial here. Split the structure, take out the data, send them in here, and I can connect from an external unit and receive it. But for now, we just make a quick demonstration for this, and later on, when I get to 3D print some proper boxes and some units and a bunch of sensor I have, I will connect them and make another video. And maybe a Delphi project as well, with like a home lab or home automation center. Yeah, something like that. Now it will send this data very fast all the time, so we want to slow this down, and I think we can use a pulse generator more here, as I seen in some examples. For this first pulse generator, we will send every 5th second. And for the next pulse generator, we can try every 2 seconds. And we add this into the clock here. Means every second is okay, actually, to update. And every 5th second the digital in here will change. So I think that is it, actually. Very fast. We can try this at first. So first we have to flash this again. So for doing that, we will move the GPIO pin, and then we will make a quick reset and then flash again. It might also be that I have many programs open at the same time, so that's maybe why it takes so many times at the same time recording and running this studio. So it might be that. In the meantime, no, maybe it's too many programs open at the same time. I think that can be it. We can try once more, maybe disconnect. Guys, once more. Now it's writing. Sorry for taking the time. Might have to cut in the video. Need a bigger computer. So when this was a success, we move the GPIO pin and we make a quick reset. And now when we have made this TCP server socket, I think we can just show that, and we can change viewing the phone again. Yeah. And we go back, refresh on this one. We can enter that unit. And we can take find open ports. And you can see we have one open port, 8080. And we scan the ports. So this is good. Okay, so now we move over to the Delphi. We can change here. So. And we can get the camera up. And this one as well. Yeah. It should be nice. Okay. So the first thing we need to have is a socket. So we can search for the socket. And we have client socket, because it was server on the other side. And on the side here, we can I'll switch the screen. Move it over here. It's better for working. Move this one a little bit. And here, down here in the host, we will add 192.168.50.10. And the socket port we specified before was 8080. And now we need to have, we made everything into a structure before, so we need to have a split structure. And I think we can double click on this one. It's overlapping a little bit. And we can make a boolean here. And then we go into and find a LED. Can place this in the middle of the screen here. You can make it larger. And when we go down to the open wire from the Visuino or Mito software, we will see these components the same way as we see them in Visuino. Very nice integrated that you can do it like this. The data from the client socket we connect into the split structure. From the split structure we take it out to the LED. And that should be it. Should be ready to compile and run the program. Yep, I don't think you see it because I need to add it to as a screen. I will do that fast. Might be this one. And we can move this here. I will slide over so you can see it. So now you see that it's working very well. This I'm quite happy about, because here in Delphi I can make my home automation lab. I can have a lot of Arduinos and connect on different sockets and reading the inputs. I have one central where I can read it, and in Delphi I can use variables writing to the Windows registry, so I can compare them and turn things on and turn things off. So a lot of these things you can buy ready already, but it's a very good hobby and very interesting thing to actually know what's on the backside of this. So yeah, that's it, people. So thanks for watching, and don't forget to click the subscribe button. Thank you. Bye bye. Have a nice evening. Bye bye. Yeah, I want to make an additional video on the end here. So The reason is because one of the camera was overlapping, so you didn't see it properly. So I will remove the camera so you can see the last connection. So yeah, this is that's it. So yeah, okay, that's all for now. Okay, bye bye.